Am I audible? ඇහෙනවද මාව?
Yes.
Yes, sir. Okay, correct. Do you have any questions to ask about past sessions? Right, let's start today's session. That is about fact analysis and the reliability analysis. So under that, we are trying to discuss how to calculate cron-batch alpha for the reliability analysis mm, and uh, fact analysis, so that in SPSS it is available exploratory fact analysis EFA. Then so at the end of the lesson you will be able to understand the purpose and applications of fact analysis, differentiate between principal component analysis and common fact analysis, perform principal component analysis in SPSS and interpret key outputs, use Fermat's and direct opin rotation methods, generate and interpret factor scores for further analysis, apply factor analysis techniques to simplify data and identify key patterns. So, once you prepared a questionnaire or especially questionnaires or any other measuring instruments, before conducting or before administering this questionnaire, so we have to check validity and the reliability. Right? එතකොට අපි question එකක් ඇදුවට පස්සේ ඒක අපි research එකට use කරන්න කලින් අපි validity and reliability බලලා ඉන්න ඕනේ. So that we can do a pilot study and we can calculate validity and the reliability. එතකොට ඒක තමයි අපි සාමාන්‍ය method එක කරන්නේ. Right? Then calculating reliability is very easy. So we'll see after enter data into SPSS worksheet. Simply we can calculate cron-batch alpha value. Based on that cron-batch alpha value, so you can decide about the reliability of the questionnaire we used there. So then here, yeah. So first we are going to find Pearson correlation and partitioning the variance in factor analysis. So that is the thing first we have to do. Then later on I will explain you the reliability. So that is very simple thing. First we'll discuss about the factor analysis. Then reliability is just within 30 seconds we can find reliability. Yeah. So in the fact, why we are doing factor analysis is sometimes some of the psychological, especially the unobserved, so there are some factors we call latent variable. So the latent variables we can't measure directly. We never directly measure කරන්න බෑ. For an example, so if you want to measure students' motivation, right, about a subject, motivation බලන්න ඕන. So motivation cannot be measured directly. For that, we are using some measuring instruments or measuring scales, right? So there are validated measuring scales. right? From the previous researchers. අපිට පුළුවන් validated measuring scales හොයාගන්න කලින් research, right? So then we can translate, or some we can namely develop that research instruments also. Doesn't matter, because if we are calculating these fact analysis and we are finding the reliability coefficients and those things, therefore we can use newly developed instrument as well. So then I want to explain you is that, so for these kind of latent variables, right, it means the variables we cannot be measured directly. Right here, one of the example is there. SPS is anxiety. So anxiety is we can't measure using. So do you have anxiety or not? Likewise, we can't ask the questions from the participants because sometimes they know didn't know about the word anxiety as well. Therefore, in that cases, so we have to use separate questionnaires or separate measuring instrument or measuring inventories to calculate these variables in our research. So the thing is that, so then the thing we are trying to find is we call latent variables. So the latent variable කියලා කියන අපිට එක කෙලින්ම හොයාගන්න බැහැ. So we have to use number of questions or number of items in the questionnaire to calculate this latent variable. So in here that is SPSS anxiety is a latent variable. For that there are 8 questions, 8 observed questions, observed variables in your questioning. So then we call those are the items. Then factors are the latent variables. And items means observed variables. These are the observed means that question we ask from the participants. In a participants ළඟින් අහන question එකට තමයි අපි කියන්නේ observed variables right? So I will show you one of the question here. So very simple one. Assumptions, the correlations among all observed variables can be explained by the latent variable. So it means that, so there should be a high degree correlation with each item with this latent variable, because we need to explain this SPSS anxiety variable throughout these observed variables. Therefore, there should be very high correlation between these items and SPSS anxiety. So therefore, we can find if there are some positive correlations, or then we can decide whether to conduct fact analysis or not. Right? Before that, yeah. So this is the anxiety questionnaire, right? These are the items in this questionnaire. So the first item, so I will show you that questionnaire. I can show you a simple questionnaire, like this one, right? Yeah. Attitudes towards statistics, technology, right? So then these are the instructions. So this question is used like a scale 1 to 5. It means strongly disagree to strongly agree. So then these are the how this is how you have to mark there. So you can circle your answer. So these are the questions in this. It means these are the items in the questionnaire. So then these are the observed variables. So the unobserved variable is SPSS anxiety. So we can measure that SPSS anxiety through this item. Right? The first one is statistics makes me cry. So statistics makes me cry. My friends will think I am stupid for not being able to cope with SPSS. Standard deviation excites me. I dream that Pearson is attacking me with correlation coefficients. I have little experience with computers. I don't understand statistics. All computers hates me. I have never been good at mathematics. Right? So these are the questions given there, and there are some other democratic informations also. Then it's mentioned that it is an optional thing. So if you like, you can answer for these questions. Otherwise, you can omit. Right? So this is a simple question here, right? So there are some data, right? Make a bit of data වගේකුත් තියෙනවා හදාගත්ත එකක්. So simple data actually. So then based on that data, then this is the practical example. So then we'll see how we can analyze, how we can use factor analysis to uh, find the validity and the reliability of this data set, right? The questions stick with our method at the end. Right. Well, first we can calculate this Pearson correlation for this statistics awareness question SAQ 8. So we know how to calculate the correlations between the items. So we can go analyze, correlate, then by variate. Then so we can select all of these items and we can send these other variables, right? Options. We can calculate, yeah, style. So no need to change those things. Just we have to find Pearson's correlation. Then here it's used flag significant correlations. Yeah. Then this is the output. Happy output the column. Yeah. Yeah. This is the output, so you can see the correlation. So if you consider that statistics may cry with my friends will think I am stupid not being able to cope with SPSS. So then here they have that minus negative 99, right? Correlation, right? Yeah, then minus negative 0.99, then minus negative 3.337, right? Negative 33.7, right? Likewise, right? Likewise, you can find the relationship and the correlation here, right? So these are the correlations. Then here you can see that is a large negative correlation and large positive. Likewise, we can find the correlations there. So there exists varying magnitude of the correlation among variables, right? So you can, yeah. So then partitioning the variance into factor analysis, right? Common variance. Variance that is shared among the set of items we call the common variance. So then communality, common variance that range between 0 and 1, we are considering a communality. Then unique variance, a unique variance. Variance that is not common. Specific variance means variance that is specific to a particular item. For a item for all components hate me. Anxiety about computers in addition to the anxiety about SPSS. So then we can take these other specific variances. Um, and error variance that existing anything unexplained by a common or other specific variances. For an example, mother got a call from her baby sister that 2-year-old son ate her favorite lipstick. So then this is not belongs to our question. Yeah. So anyhow, that is depends on sometimes that the situation. So then we could take it as a variance like that. So then variance partitioning in principal component analysis. So here total variance we can take it as 1. And communality is equals to square of um, communality. So then it is also equals to 1. In principal component analysis, there is no unique variance. Common variance are across a set of items makes up to total variables. Total variance. Right here you can see this is our factor structure of our questionnaire. Make it a factor structure of our questionnaire. Okay. Then this is the common variance. So then this is our latent variable SPSS anxiety to test this SPSS anxiety. So there are several items there. So this we call that is unique variance. right? So then since community is equals to h square, so we can find unique variance 1 minus h square. So the total variance is made up with the common and unique variances, right? So then there we can find the total variance. Right. Factor extraction plus factor rotation. So factor extraction, the type of the model. So then we are using principal component analysis. So exploratory factor analysis. So we can think what is the method we are use. And also there are some other estimation methods, right? Like principal axis factoring, maximum likelihood. Likewise, there are estimation methods. I will show you so once we are doing our analysis, so you can choose the estimation method, right? And also number of factors or components to extract, that is also there. So how many factors we need? කියන්නේ දැන් මෙහෙම එකක් තියෙනවා. දැන් අපි question එකක් දීලා so මේක අපි කරන්නේ correlations තියෙනව හොයාගන්න එක. So then here they are asking number of factors do you want to extract from this data set? කීයද factors ඕනේ කියලා අහනවා. Otherwise so we can use these eigen values as well. Then it means they are based on the correlations between the items they will produce some components there. So these are the two ways to do. So sometimes we can consider how many factors we need, or the other thing is based on these eigenvalues we can automatically find these factors. In next thing is factor rotation, achieve simple structures orthogonal oblique. Sometimes we have to use this factor rotation. So how many times we have to do these fact analysis to extract these factors. So therefore we call these factor rotations. Normally we are doing 100 times or more this factor rotation. Right. So then extracting factors. We'll see how we can extract the factors from our questionnaire. So then here we are trying to discuss then principal component analysis. Principal component analysis with 8 and 2 components. So the 8 components වලට කොහොමද අපි වෙන් කරගන්නේ? ඒ වගේම 2 components වලට ගන්න කොහොමද කියලා බලනවා. Then the other thing is we are trying to use one is principal component analysis. The other one is we are going to use the common factor analysis. So principal axis factoring. So 2 factors from this principal factor analysis. Factoring how we can choose 2 factors there. And also I'm trying to use this maximum likelihood uh, or method also to extract 2 factors using that method. Right. So then we'll see how we can do the principal component analysis using this data sheet. So a goal is to replicate the correlation matrix using set of components that are fewer number than the original set of numbers. Yeah. So then here you can see we can see that there are 2 components principal. So then we are going to divide. අපි මෙන්න මේ තියෙන set එක, then there are 8 factors no. So we are going to gather this information with according to their correlations. Two what do you call two variables, actually 2 latent variables. For the 2 components, these 8 variables we are going to gather for 2 components. We'll see how we can do it. Right. So these are the methods we can do based on the eigenvalues. So I will show you what is eigenvalue. Total variance explained by the given principal component. So if the all of the eigenvalues are greater than 0, that is, then its model is good. So then negative eigenvalues means ill condition. So sometimes we can see that negative eigenvalues are as well. So therefore, but it is not actually good if we have that more eigenvalues. It may be sometimes 1 or 2 negative values, doesn't matter, but if all the values are negative, so it is not good. And so this and the other one is that if that my eigenvalue is greater than 0 is good. So negative eigenvalues we can call ill condition. Then eigenvalues are close to 0, that is multi-collinearity. So it means that so the relationships that we can find, right? um Then eigenfactors. So the weight for each eigenvalue, so we can find, we call those are the eigenfactors. Then eigenfactors times that square root of the eigenvalue, so component loadings. The eigenfactor we can find by taking the square roots of these uh, factors, eigenvalues actually. So then component loadings, correlation of each uh, item with the principal component. We call that component loadings. It means that, so there are many factors now. So then from each factor, so we can find this correlation. So it's called component loadings. Eigenvalues are the sum of the squared component loadings across all the items components. So then we can fill in the eigenvalues means sum of the squared component loadings. So we can find the component loadings. Then so find uh, we can find the square of these all these component loadings, and if we add this, that is we can call as the eigenvalue. Right. We'll see how we can use this principal component analysis to uh, divide actually to gather for 8 components. Components අටකට අපි කොහොමද ගන්නේ කියලා බලමු. Note that factors are not the same as the components. 8 component is not what you typically want to use. ඒක අපි decide කරපු එකක් 8 use කරන්න කියලා එකක් නැහැ. Right? So we can, based on the eigenvalues, so we can gather the information sometimes. So then we can take that for the one component. So I will show you later how we can use these eigenvalues to gather these components, right? So now we can use the other data set. So there are 2571 data entered to here. Right. So then we are going to do the principal component analysis now. So then it goes to analyze. Here we are using dimension reduction, fact analysis, right? So this is the step we are going to do. Analyze, dimension reduction, then fact analysis. Right. We can use every variable for the fact analysis. So we can select all and we can have 4. Then descriptives, no need. So coefficient, determinant, curve. KMO Bartlett's test we can tell here. Then extraction. Extraction method we have to select. So then extraction method is principal components. Principal components. Right. From there, we have to select principal components, right? Then we can use uncorrelated factor solution and street plot as well. Then we use correlation matrix, and so we are not going to extract based on the eigenvalues. So we have to extract any fixed numbers, fixed number of factors, because we decide at the beginning. So we need 8 components there. Then maximum iterations and convergence. So we decide we have to rotate this 100 times, right? Then we'll see continue and okay. Right. So then here we perform the factor analysis, but we didn't get the output there. We'll see. Right. So we need this output. So, but it is not given there. Then we conduct again. We can go analyze dimension reduction, factor analysis. So then we can see the factors, extraction method, principal components. Okay. The descriptives. Right. It is there. No, it took time. Right. I gave the instructions again. So this is the fact analysis now. So these are the outputs. Within outputs, the fact analysis. Okay. Right. We'll try to explain one by one from there. Here you can find the method we used here is that principal component analysis. We'll see how we can use this principal component analysis for this example. Right. The first one is component loadings. Then correlation of each items with the principal component. Right. So then we'll try to take this one first. What is that? Component matrix. Component matrix is this one. Here you can see this component matrix. Then it is mentioned there 0.6591, 0.136, right? 0.659, 136, negative 398. So this is this output, right? This is that output. So we'll see that what is explained by this output. මොනවද එකකින් කියවෙන්නේ කියලා අපි බලමු. Yeah. So these are we call component loadings. It means correlation with the items with the principal. Then some of the squared loadings across the components is we called community. For an example, if we take this 6.59 squared is equal to 0.4434, then it means that 43.4 of the variance explained by the first component, like this r squared. Right? Then second one is 0.136 squared is equals to 0.018. It means 1.8 of the variance is explained by the second component, right? Then sum of the squared loadings with the column component. So we call it as eigenvalues. Then here sum of the square. So we need to add this source, 8 components extracted. Down each column, make column, make column, make. So then we can take this sum of the loadings. So then it's equals to I will try to show you it. Right, we'll see to take this sum of the squared loadings there. Then we'll try to get these answers. Right.
Excuse me, you are in the output or in this matrix?
Yeah, so then here I am in the presentation, right? So that is taken by the output.
Okay, so can you please explain this 0.659 square, this one equal to 0.4?
Yeah.
So we cannot see this part. That's what we cannot understand.
Okay, that's why I'm trying to explain that using Excel sheet. So I will take this to Excel and I will show you how we can get these values. You need to understand how you will get that
Yeah,
3.057
equal,
everything. Yeah.
yeah,
Yeah.
equal number so that we can want to see where from that.
Yeah. Yeah. So,
Yeah, yeah.
okay. So then we can see that in the output as well. So I will show you how we can take it.
Okay.
right? So this is the output there, right? Then we can take this we call communities, right? So then sum of the square loading across the component we call community. So it means, so then we can say we can take the square of this all, right? Again, I will take for an example. We can calculate communities here, right? So I'm going to calculate communities now. Right, it is, we have to square this one. This is the value 0.434. Right, I will take this for 3 decimal points here. So these are the values, right? That is mentioned in the second one, 0.018, right? So we can take the square of these values, right? So then we can find the square of all here, right? So if we add this all, we call this is equals to, this is what we can take there. Mm, yeah, that is this 3.057, right? Right. Then this is 1.067, 0.958. Is it clear now?
Yes, yes, it is clear
Yeah,
now.
yeah.
Thank you.
So then these are we called these are the eigenvalues, right? So these eigenvalues are given directly in this output. So then this is how we can calculate those eigenvalues, right? Right. Next one is next output. Uh, right. Next output is total variance explained. Total variance explained. This one, this table. Right. So we can talk about this table. Right. So you can see these values here. මේදීන් අපි හොයාගත්ත values ටික. Right. This one. 3.057. 3.057 is here. You can see there. Yeah. These are the values we 3.057, then 1.067, 0.958, right? 0.736 here. So we call these are the eigenvalues, right? Eigenvalues, right? These are the eigenvalues. So then initial eigenvalues is there, right? So yeah, so so we use some extraction, some of the square loadings we can see there. So that is also same here, right? Same here, right? Yeah, so then after the extraction, so then here you can see some of the extraction, but it remains that these values equals to same values, right? So then you can see why that left column same as the right. So It's actually extraction sum of the squared loadings equals to eigenvalues. Therefore, it remains as same these eigenvalues. Right? So based on these eigenvalues, when we eigenvalue එකමුත් අපිට පුළුවන් automatically. Sometimes we don't know about how many so how these our I mean sometimes we cannot see that how this is මේක අපි කොහොමද බෙදාගන්නේ කියන එක අපි දන්නේ නැහැ සමහර වෙලාවට. Right? කියන්නේ no idea. So for that we are using this අර correlations relations තියෙනවා එකතු කරගෙන අපිට පුළුවන් හදාගන්න. Right? So for that we are using that factor analysis sometime. එතකොට we can use this this what we call eigenvalues to eigenvalues එතකොට අපිට use කරන්න පුළුවන් අපිට variables හදාගන්න. Right? It means yeah, variables are latent variables, unobserved variables. So we can gather some items and we can make a variable. තියෙන items කීපයක් එකතු කරලා variable එකක් හදාගන්න පුළුවන් correlations තියෙන අපිට නමක් දීලා. Right? So ඇත්තට මේකට අපි මේ factor analysis use කරන්නේ. So for that these eigenvalues we can use. Right. Then another one, this is we call scree plot. Right? So then here you can see you can take because if that eigenvalues are greater than 1, then it's good. It's good, no? So then here that for that we can use this scree plot. So then this is component number and the eigenvalue. So simple thing, scree plot means here component number. So these are the components we have 1, 2, 3, 4, 5, 6, 7, 8, right? With the this is the x-axis. Then in the scree plot, so simply we can draw a line graph like this. So then that is what we call that scree plot. It's right, I will take this for scree plot. I want to take the values to scree plot 1, 2, 3. Here this one, we need this one. Yeah, so then we can draw report like this, insert recommended graphs. I need this one. This is we call scree plot. Right, scree plot, options, format, right, markup. Right, so this is the scree plot there. Make them a scree plot because this is same as this one. මේකම තමයි මේ වෙලා තියෙන්නේ. Right, scree plot එක. එතකොට eigen component number and the eigenvalues. So what that is in the x-axis we have to use component number, in the y-axis eigenvalues. Right, so this is the scree plot. Then here you can see an right. So then here we consider the eigenvalue. So then here we can see the elbow. So then here, then each scree plot we can observe this elbow here, right, like this. Right. So then so you know that earlier we explained that if the eigenvalues are greater than 1, that is good. In here we mentioned there. Yeah. Then here you can see if the eigenvalue is greater than 0, it is good. So the negative value, that is ill conditions, right? Eigenvalue close to 0, that is, it showed that multicollinearity. So then here we can see that. Then these are the things. So then eigenvalues are equals to 1 is actually good. Greater than 0 is good. Then all the values are greater than 0 here, right? Since commonality is 1, if in principal component analysis, for a single item, the eigenvalue is greater than 1 is explain the community of more than one item, right? So then here, that's what we can take from this scree plot. So then here, if we are based on these eigenvalues, the eigenvalues are අපි බෙදා ගන්නවා නම් අම පස්සේ ඉස්සරහට පෙන්නන how we can um, right how we can separate the items to variables for latent variable using the eigenvalues. Eigenvalues වලින් කොහොමද වෙන් කරන්නේ කියලා අපි බලමු. Then here we use 8 components, right? It's we decided, අපි decide කරලා දුන්නේ 8 components කොහොමද ගන්න කියලා, right? So then we can see that is in this street plot in the other output. Okay? Right. So we'll try to do the principal component analysis. Then earlier, so here we use at time we use principal component analysis, but here the factors to extract we mentioned as 8, right? මෙතන අපි 8ක් දාලා තමයි කරන්නේ. Then that is decided by us. අපි decide කරේ මොකද මට 8ක් ඕන factors කියලා මම හිතුවා, right? So then here that again I am going to do that. So then here now I am decided to number of factors, 2 factors I need to reduce. Actually these are the we call for to find the factors, no, the relationship. So I'm trying to get for these 2 factors, right? Same process, right? Same process. The thing is that so we need to reduce that number of factors to 2. Earlier it's we take as 8, right? right, එතකොට අපි components 8ක් කරන් components 8ම වෙන් කරන එක. එතකොට අපිට ඇත්තටම fact analysis ඕනෙත් නැහැ නේ. එතෙන් තිබ්බේ 8ක් විතර, right? But our target is we need to reduce our items to the variables. ඇත්තටම අපි මේ dimension දැන් අපි ගොඩාක් අපි හිතමු ඉන්න question එක there are 53 items. I want to redact for the 2 or 3 items, 2 or 3 variables actually to find the relationships, right? එහෙම නැත්නම් අපිට ඔය 52ම එකට අරගෙන ඉවරලා අපිට කියන්න බෑ, අපිට find බෑ relationships, අපිට හොයන්න බෑ ඇත්තට. So that's why we are using these dimension reductions. දැන් අර මෙතන පොඩි question එකක් ගත්තේ. ඒකේ 8ටම අපි ආයි components වල අපි ඇත්තටම fact analysis කරලා වැඩකුත් නැහැ, right? ඒතර මේ more practical වෙන්න අපි මොකද කරන්නේ? So we have to based on the eigenvalues, so sometimes we can decide. Then we are then he is in this one we are going to decide. It's a අටක් ගත්ත දැන් අපි දෙකක් ගමු. Same process, right? Process එක එකම තමයි. Right? Here we are going to fix number of factors. Then we are going to reduce this 8 to 2, right? The same process. So we can go, right? We can go, right? Analyze, then dimension reduction, fact analysis, same thing. Extraction we have to go principal component analysis, that's okay. Correlate, everything is same. So I'm going to reduce this one. Number of fixed factors here mentioned as 8, so I'm going to reduce it to 2. Fact analysis, so we'll see the outputs. Yeah, total variance explained, this one. So the eigens values remains same, right? Eigenvalues ටික වෙනස් වෙලා නැහැ, ඒක එහෙමම තියෙනවා, right? they තියෙන initial eigenvalues, right? පටන් ගත්ත eigenvalues ටික තියෙන because there are 8 components there. ඉස්සෙල්ලත් factor rotation කරලා 8ක්ම ගත්තනේ. දැන් මට ඕනේ I need 2 factors. මෙන්න තියෙන extraction sum of the square loadings, right? මම දෙකක් extract කරලා අරන් තියෙනවා. So then here you can see there two factors are, like one is that 3.057, the other one is 1.067. These are the 2 factors actually, right? So that nice, notice that only 2 eigenvalues there because we need only 2, right? We are going to extract for the 2 components, right? Right. 84.0% of the total variance in the item 2 is explained by the component 1, right? Okay, so then here you can see here the 2 eigenvalues. Then the communalities, you know how to find the communalities, right? That is square of this correlation. So we discussed that when we found the correlations. Then these are the actual correlations, correlation matrix, right? So we can take the correlations, we can find the correlations, then we can take the square of these correlations, square of these correlations, right? Then that is we call communities. Then if we take this sum of the squared of the correlation, so we call these eigenvalues, eigenvalues, right? Eigenvalues. Right. This is actually theory. This all of these things. You don't need to know how to find these things, but you have the idea that what are those things. Right. Yeah. So then here, if we consider that, then extraction is there, initial and extraction. Um, yeah. Then here you can see that here the communities you can see that initial and extraction. So then first one initial is 0.457. It means 45%, 3% is explained. Then I we have to show that. So then earlier one, okay. Then here, yeah, output. Sorry. Here that communities is equals to 1 there if we take the sum of the communities. But in here, so after the extraction, so that is not equals to 1 here. Communities are not equals to 1 now. After the extraction. Extraction එකේදී එකක් ආවෙ දැන්. Initially again 1 now. ඔය හැම එකේම 1 තිබුණේ. So after the extraction, so it's become like that. So then first one is 0.57. It means what? 44.3% of the first items is explained by the item number 1, right? Total variance එකෙන් 45% 3 තමයි මේකේ item number 1 එකෙන් එන්නේ. දැන් මේකේ තියෙන 84.0 means that, sorry, 0.84 means 84% of the total variance of the item 2 is explained by this component 1, right? Likewise, right? Right. So then we'll go to another one, another method. So how to extract factors. Factors take extract කරගන්නට අපි බලමු, right? Using actually this is exploratory factor analysis actually. So we are trying to use two methods. There are more than two methods, right? You can try. The methods are same. So we are going to trying two methods. One is that common factor, sorry, principal axis factoring. So then we are going to again as fixed factors for two factors we are trying. They're using the same question, yeah, and maximum likelihood factoring. So then that's also we are going to try for two factors. Okay, we'll see how we can do it. කොහොමද ඒක කරන්න කියලා පොඩ්ඩක් බලන්න. Right. So factor analysis. So goal is that you have to know that's actually factor analysis. So I'm again telling you that this is exploratory factor analysis. So someone need confirmatory factor analysis. So you have to go for another software because that is not available in SPSS. Will same that this is IBM SPSS statistics now. As same as there is another software called IBM SPSS AMOS. Right? If you use this AMOS software, so you can do the confirmatory factor analysis, but confirmatory factor analysis is not available in SPSS statistics software, right? So then here in exploratory factor analysis, so the thing is that so the goal is to actually uh, reduce the dimensionality, but assume that total variance can be divided into common and unique variances. එතකොට මේක අර ගලන් කතා කරා වගේම මේක අපේ goal එක තමයි we have to reduce these items, right? So this is our um, questionnaire we are using, that we need we taken some practical example. So may practical example sometimes it may be not produce results in this example anyhow. That so I am trying to explain you the method. මම try කරන method එක දෙන්න හොඳ results දෙන්නේ නැති වෙයි සමහරට. මේ අපි හිතලා ගත්ත values දෙන්නේ ඇත්තටම කරපු එකක් නෙවන හින්දා සහ items 8යි තියෙන්නේ. So yeah, you know that in a questionnaire there are more items than that, right? Here that we found the correlations, right? Uh, then we are trying to get some variables, right? So using this exponential factor analysis. So then in our example, there are 8 variables, actually 8 items. So then we are going to find yeah, factor analysis. So then we are trying to use. Can't you hear me properly? Your internet connection is unstable here. Can you hear me properly?
It's not
Am I
stable.
audible to you?
Yeah, not stable.
That's fine. Now it's okay.
Yeah, it's okay. Again, some
Why is that?
kind of
Can
things
hurry there?
happening. Oh, now it's okay.
Yeah, okay. Right. Um, right. We'll go for analysis. We'll go to the data set, right? Then again, we can go analysis. So first, we discuss principal component analysis, right? Then we are going to trying another method called principal axis factoring, right? So then we are going to use the factor analysis, right? Principal yes, my data set. Okay. Then again, we are going. I'm not going to use these eigenvalues for the first example. So I am fixed number of factors I need. So I took 2 factors. I select 2 factors from there. Yeah, that's all. And we can continue extraction. Fix 2 factors. Okay. Then okay, we can see the output. One by one, we'll try. Yeah. Yeah, so then here we can see in the output. Yeah, sorry. Principal component analysis. So I need the principal axis factoring. So some error is occurred there. So I will try again. Analysis, dimension reduction, factor analysis, extraction method. Yeah, I have to change the principal factor, say principal axis factoring. Okay, then okay. Right. Yeah, so this is the output, right? This is the output now. So then here you can see the initial communalities, uh, 0.293, 0.106, 0.298 likewise after the extraction. So you can see here 0.437, 0.52 likewise. So the elimination communities are the squared multiple of the correlation coefficient controlling for the other items in our model, right? So yeah, some of the communities are across the items. So if we take this sum, මේක එකතු කරලා ගත්තා නම් that is 3.01, right? That is 3.01. Yeah. So if when it's come to the factor analysis, again initial eigenvalues are same because the same data set we used. Then here we use principal axis factoring. So then we can extract two variables actually. Then here you can see one is this one, right? Yeah. So unlike the principal component analysis, the sum of the initial eigenvalues do not equals to the sum of the squared loadings, right? Now eigenvalues then here not equals to sum of the squared loadings in this method, right? So the sum of the eigenvalues here we can take 4.124, right? 4.124 is the sum of the eigenvalues here. The reason is that eigenvalues in the principal component analysis, uh, then that is not actually factor analysis method. Then so the sum of the squared loading of the factor one, right? Sum of the squared loading of the factor one equals to 2.511, and sum of the squared loading of the factor 2 is 0.499. So the sum of the communities across these all items is we found as 3.01 there. So then here, if we add this all, we can take that as 3.01. Right. So then, yeah, then this is a principal axis factoring used for two factors. No? And ඒක අපි decide කරලා ගත්ත එකක් නේ. Then based on the eigenvalues වලින් අපිට පුළුවන් decide කරන්න factors කීයකට අපි බෙදා ගන්න කියලා. Right? We'll see it now. Then yeah. So then we can use these eigenvalues. Then if the eigenvalue is greater than 1, so we can categorize into groups. But so you know that eigenvalues are only for the principal component analysis. We are not using in the exploratory factor analysis there because, right? So then here also you can see that if you look at this is the tree plot we used earlier example, right? So then you can see this elbow, right? So yeah, okay. Just I will show you අපි පොඩ්ඩක් අරකින් නිකන් ගිහිල්ලා බලමු. So then factor analysis, dimension reduction, factor. So then extraction method I will use principal components, right? Based on the eigenvalues. දැන් අපි අර ඉස්සර දෙකකට බෙදාගත්තා. Then based on the eigenvalues, just we'll look at how they divide into again factor analysis. Yeah. So again they divided into two, right? Based on the eigenvalues also, right? Uh, Here there are two factors extracted there. 3.0571 factor, right? Two factors extracted here. Two components extracted. Components දෙකකට බෙදලා තියෙනවා අපෝ ඒ කියන්නේ මේ eigenvalues වලින් ගත්තා, right? So these are the two components. One is the extraction of the sum of the squared load is 3.057. ඒක අර value එකම වෙලා තියෙන. The other one is 1.067. So I will explain this further. මම ඉස්සරහට පස්සේ explain කරන්නම් මේක. ඒතර ඕක සමහරවිට අපිට බෙදා use කරන්න වෙනවා. අපි අර question answer දැන් අපි කීයකටද බෙදාගන්නේ කියලා අපි දන්නේ නැහැ variables. අන්න ඒ වගේ අවස්ථාවක අපිට ඒක use කරන්න පුළුවන්. Right. Yeah, so then actually like this is yes how to use this factor analysis in SPSS. No, I think if you are not familiar with these things, it's better to use some online reference, right? To understand about that these methods, why we are using these methods, right? And how we can extract the data from that. So you can not if that is 1 hour is enough for that, right? So just read and understand what are the things given by these values, right? So පොඩ්ඩක් එක කියවලා බලන්න if it is unfamiliar to you, right? Mm, we'll see the factor matrix of previous one. Uh, this one. Then we'll see the factor matrix. Factor matrix is where, yeah, this is the factor matrix. We can see there 0.588, 0.43. Then extraction method is principal axis factoring. Two factors extracted, 79 iterations required. To extract these two factors, they use 79 iterations. ගිහිලා තමයි මේ factors දෙකක් කරන් තියෙන. එතකොට මේක අපි SPSS වලින් just දුන්නාට, so this is actually a long process if we use these manual calculations, right? So we have to repeat it 79 times to find these two factors. Right. So then we'll try to understand what are the things that are included this factor matrix, right? Yeah. So then here we can calculate the sum of the commonalities there. So 3.01, we found it earlier as well. And the eigenvalues we can take, that is, if we add this one, right? The squaring the loadings of the summing up gives either the community or the extraction sum of the squared loadings, right? The summing down the communities for the across eigenvalues of the total variance is explained by 3.01. මේ අර අපි ඉස්සලා කරා වගේම sum. මේවා කරලා මේ value එක ගන්න පුළුවන්. Right? So then sum of the squared loadings across the factors community. So it means sum of the squared loadings. So you know how we can take this, right? If we take the sum of this, sorry, we can square this one. So this is, then we can take it as 0.346. It means that 34.6 of the variance in the first item is explained by the first factor. The next one is negative 0.303. If we take the square of this one, that is 0.091, it means 9.1 of the variance of the item 1 is explained by the second factor, right? Likewise. So then there are two factors. Then what we can do is that we can add these two factors. Then 0.437, if we add these numbers, then 43.7 of the variance of the item 1 is explained by the both factors. And they came up right? So if we take this sum of the squared loadings down of the extraction sums, that is uh, that is extraction sum of the square loadings, then this is not eigenvalues. Eigenvalues are not given is factor matrices. So eigenvalues, there is separate method to find the eigenvalues there. So then that's why I explained that. So we are using that in the principal component analysis only, we are using the eigenvalues. So based on that eigenvalues, we can find some variables there when we use that principal component analysis. Right. Then we'll go to the factor matrix again. Here, extractions. Then these are the communities of cumulative values. So then it's come to the I as well. Right. So then here, these are the factors 0.588, 0. Negative 0.337 statistics may cry Tarantino. Right, extraction sums we can find here. This one. Right, 31.382. Here we can see 37.621. When interpreting unrotated loadings, most total variance are explained by the first factor. But ගොඩක් වෙලාවට මේ unrotated එක පාවිච්චි කරලා ඊට පස්සේ අපි rotation methods උත් පාවිච්චි කරලා this is the bar diagram actually only the selected loadings is shown, right? So then statistics anxiety with the item 1 0.588. These are the factor loadings actually. Factor loading කියලා අපි කියන්නේ, right? So then 0.59, that is the factor loading, right? So then with the item 2, that SPSS anxiety factor loading is 0.227, right? It means then within use 2 decimal points, that is 0.23. And for the third item, that's factor loading is 0.56, right? Uh, so then the second one, right? This is the second, we call the second unobserved variable. So it's name it as tech anxiety. So if we consider that one, so you can see here. So this is not written there uh, because that is a negative one. So we need to take the positive at අපි 0 point. Yeah, this one. So if we consider this one, take anxiety with the item number so that we can take these relationships. So right. So මෙන්න මේක තමයි දැන් මෙතන extra. එතකොට දෙකක් තියෙනවා. Red factors දෙකකට අරන් තියෙන එකක් SPSS anxiety කියලා name එක දීලා තියෙනවා. You can write the name. The other one is X anxiety. So then using this questionnaire, same questionnaire, so we can explain too, right? That's what we found these relationships. Sometimes if these relationships are not, එතකොට මේ relationships ටික අපි ගන්න if it is not strong relationships හොයාගන්න පුළුවන් මේ exploratory factor analysis එකෙන්. If this is not too strong, then we have to go for a confirmatory factor analysis to confirm whether these results are good or not. So ඒක අපිට SPSS වලින් කරන්න බෑ. You have to go for another software to do the what we call confirmatory factor analysis වලට තව software එකකට යන්න වෙනවා, right? ඒ කියන්නේ AMOS වලට වගේ එකකට යන්න වෙනවා. Right. The relationship between the three labels, right? එතකොට අපි කතා කරා factor component matrix, right? Factor component matrix, this one. And the other squared loadings. So we'll show that squared loadings there, right? These are the squared loadings. Then the other one is squared loadings. There are two communities, some across the factors or components. Then we call that is communities. So then if we add the other things, eigenvalues in the principal component analysis, අපි eigenvalues කියලා ඉන්නවා, or the sum of the squared loading is principal principal axis factoring, right? Then sum of down these items, sum of down the factors of components. So we can take total variance explained. So then in the principal component analysis, so we can see 8. So yeah, so that is actually yeah. So here you can see this is square loadings is actually a calculated element, right? These things we can see in the SPSS out table, right? So that actually there is the relationship between three tables. So we need to understand what is the relationship there, right? Right. So we'll go to another one that is maximum likelihood estimation. So that I told you that some if there are no rotations. So here we'll show you. Yeah. So when interpreting unrotated loadings, so these are the unrotated loadings. Most of the total variance explained by the first fact එකෙන් තමයි ගොඩක් ඔය total variance එක explain වෙන්නේ මෙන්න මේ first fact එකෙන්. අයියේ අපි අර rotation method එකක් use කරේ නැති වුණා. තන්න ඒක මග අරව ගන්න අපිට පුළුවන් rotation method එකක් use කරන්න, right? So this one maximum likelihood estimation. So then we are going to use the rotation method, right? For the same okay, same question එකටම ගමු, right? So everything is same. The difference is we are going to use extraction method. We are going to change for the maximum likelihood. Then Yeah, the other, every other values are same. Like you go to the data set analysis, dimension reduction, factor, rotation method. Sorry, uh, rotation method also we have to select. Extraction method I am going to change to maximum likelihood now. Okay, maximum likelihood. Yeah, so just we'll take first, for instance, I'm going to okay this, right? Then we'll see here the new thing is, yeah. So you can see the chi-square values there. Chi-square value that is 198.617. Value is 100, yeah, 198.617. This is telling us we reject the two-factor model. Okay. මේක significant එකක් ආවොත් අපිට මේ two factor model එක අපේ significant කියන්නේ 0.00 අපිට මතකයි අර කලින් කරාගේ අපේ මේක 0.05 කට අඩුයි. Then so if you have that මේක මතක තියාගන්න දැන් අපි there is a current hypothesized model නේ. දැන් අරන් තියෙන model එකක් තියෙනවානේ. Right? If that is here this value is significant. 0 ඒ කියන්නේ 0.05 වලට වඩා අඩු value එකක් ආව නම් මේ තියෙන model එක අපිට reject කරන්න වෙනවා. So we have to go for a new model. එහෙනම් අපිට අලුත් model එකකට යන්න වෙනවා. Right? Okay. Yeah. So we'll see these chi-square values. මේක තමයි අපි factor rotations වලින් ඇත්තටම factor analysis වලින් කරන්නේ. මේක එතකොට මේ values ඔක්කොම calculate කරලා තමයි SPSS වලින් ඔක්කොම එකපාරට දෙන්නේ. Right? The first model is uh, chi-square degrees of freedom goes down. The first model එක මේක අපි 8-factor model එකක්, not possible in SPSS, right? So then we are going to find for the two factors. So the first one is chi-square values. So 5.5308 degrees of freedom 2 and when the method available p value එක less than 0.05. Then the iteration need 4. less than 0.05 ගැන අපේ මං කිව්වා අර කලින් ඉස්සලා කියද්දි ඒක 0.05ට වඩා අඩු නම් that is significant, then model is not good, right? එතකොට second one ඊට පස්සේ ආපහු rotation එකක් යනවා, right? rotation එකක් ගිහිල්ලා ඉවරලා chi square එක 198.62 වලට reduce වෙලා තියෙනවා, degrees of freedom 3 but same that තාමත් ඒක significant, then 0.05 වලට අඩුයි ඒක, therefore we can't take that value. So then when it's come to third number of factors, now it's 3 factors තුනකට ඇවිල්ලා තියෙනවා, right? factors තුනකට බෙදුනට පස්සේ 13.81 වලට chi square එක අඩු වෙලා තියෙනවා, degrees of freedom 7. Now it is 0.057, 0.5 ඒ කියන්නේ 0.06, that is greater than 0.05. එහෙනම් අපිට මෙන්න මෙතෙන්ට ගන්න පුළුවන් after 57 iterations. So it's come to 57. So then with it's very good model now. Then three-factor model is preferred from the chi-square. එතකොට factors තුනකට අපිට මේකෙන් බෙදා ගන්න පුළුවන්. I think idea එක එන්න ඇති කියලා හිතනවා චුට්ටක් හරි. Right? So then that is how we can decide how to ඒක SPSS වලින් අපිට කරගන්න පුළුවන් how to take the number of factors there. Right? Right. So then so with this what you call then sometimes this warning we can see in the SPSS, right? So you cannot request as many factors variables in any extraction method expect principal component. The number of factors will be reduced by 1. If the degrees of freedom is -7 is not positive, factor analysis not be appropriate. So sometimes you can see this uh, right. So that is the output. Yeah, this one see, yeah, we discussed those things. Like comparing EFA and ECA. දැන් අපි බලමු principal component analysis and exploratory factor analysis. So what are the similarities and differences? So we use these two ways actually. So then here you can see that in EFA, total variance explained is equals to total community was explained by the total variance. For both metals, community is the total proportion of the variance due to all factors or components in the model. Right? In that common factor analysis, total variance equals to 1. Right? So then here, if we consider these items, right? Yeah, so then this is actually difference. So to make a total variance explained equal when right? So then we can take the sum of the squared loadings there. But if when it's come to the principal component analysis, total variance explained is equal to total variance. So that is the actually major difference between this principal component analysis and the exploratory factor analysis. Right. Now we are going to a rotation method. So everybody rotation method declare now. Uh, right. So simple structure, varimax rotation and direct opening rotation sort of here. චුට්ටක් බලමු කොහොමද අපි මේ fact analysis එක තව චුට්ටක් advance විදිහට කරා කියලා. Yeah, it's definitely you have to follow this again. And I think if you cannot understand properly. අර pixel then here it has high loadings of the one factor only input. Right? So then here we can take another factor. Then the goal of this rotation is to achieve the simple structure. එතකොට මේ rotation methods අපි පාවිච්චි කරන්නේ අපි මෙන්න මේ වගේ factors වලට හරියටම බෙදා ගන්න. Right? So but when it's come to there, this is simple factor, but simple structure actually because the other factors are 0, no, then these 0.0 second factor and these two items for the third factor. That's easy now because the other simple structure, right? Most items have the loadings more than 1, right? 0 main method. Then how we can change this one? Factor 3 has high loadings. Then if this is not a simple structure, so we have to go for a two-factor solutions. That means for a rotation method. Without rotation, first factor is the most general factor onto the most items explained by the amount of variance, right? So then there are two ways we are going to discuss. That is orthogonal rotation method. That is very much maximizes the variance loadings with the factors while maximizes the difference between the high and low loadings on the particular factor, right? Now we make බලමු. We'll see how we can do this. We are going to use the rotation method. Principal axis factor rotation right? So analyze, dimension reduction, factor analysis. Extraction method is principal axis factoring. Number of factors equals to 2 kilo. Okay. Then rotation method I'm going to use very max rotation. Number of iterations 100. Continue loading plots also. Right. Yeah. Then factor transformation matrix, then factor matrix, factor transformation matrix to rotated factor matrix. Right. So then here you can see the factor yeah. So then we'll see that. So we can okay, then we can see the output. Factor transformation matrix. Here, so this is the factors transformation matrix. You can see there the values. Extraction method, principal axis factoring, rotation method, varimax with the Kaizen normalization. Right? The factor transformation turns into regular factor matrix, rotated factor matrix. The amount of rotation is the angle of rotation here. But මෙන්න මෙතන අපිට factors දෙකකට අපි බෙදාගෙන තියෙනවා like this. Okay. Hmm. Right. Rotated factor matrix. Right. Factor matrix and rotated factor matrix. Then this is the factor matrix. This one 0.588, 0. This one the factor matrix, and these are the communities values. අපි ඉස්සලා calculate කරපේවා. Then this is the rotated factor matrix in here 0.46. Likewise, then it's here it's given rotation converge 3 iterations. Iterations to not get then 2 factors extracted for the 79 iterations required. Right? The communities then remain same. When we the communities remain same. Communities are the same, right? But we'll see what are the differences there. So then here, here it's 0.02, right? 0.02 is there, then it's changed to 0.129. Likewise, there are many changes in my values. If you consider this one, this come to a 0.811, right? That's why we are using these rotation methods. Right, so then this is the unrelated solution. බලන්න අපි factor loadings එකෙන් unrotated solution here. ඉස්සෙල්ලා අපි මේ දැකපේක only the selected loading shows. High absolute loadings very much is x hand side. ඉතින් මේකේ 0.12, 0.2 වෙලා තියෙනවා, 0.47, that is 0.44, 0.51, 0.88, and 0.19, that is 0.27. Likewise, we can change this rotation. Then here 0.59 change to 0.65, like likewise, right? So that's why we are using these rotation methods to improve these factor loadings. So අපි explain වෙන ප්‍රමාණය අපිට වැඩි කරගන්න පුළුවන්, right? Okay. Then total variance explained 2 factors. Total variance explained. Yeah, total variance explained. So here you can see it's 2 factors. They are 31.382. Maximizes the variance of the loadings, that is 37.621 maximize කරලා තියෙනවා, right? So here if we add these two, the value is 0. Extract කරාට පස්සේ value එක වෙලා තියෙන්නේ 3.01. So if after the rotation method again 3.01, the value is same, but it maximizes. Okay, it maximizes the values, right? So මේක අර ඉස්සෙල්ලා අපි මං කිව්වනේ අර rotate කරේ නැත්නම් වෙනවා කිව්ව වැරද්ද තමයි first fact එකෙන් තමයි ගොඩක් ඒවා explain වෙන්නේ කියලා කිව්වා. but මෙන්න බලන්න මේකේ 2.551 තියෙනවා, මේකේ තියෙනවා 0.499. මේකට ආවට පස්සේ බලන්න rotation එකේදී දෙක balance කරලා අරන් තියෙනවා එක මට්ටමට without changing these values. Right, so that is what we are doing. Even though the distribution of the variance is different, in the total sum of the square loadings are same. Total sum of the square loadings remain same, and also this cumulative percentage is also you can remain as same. Then variance, total variance. Then here in the first model, then before the extraction or before the rotation actually, so the first factor, the total variance 31.32 of the total variance explained by the factor 1. Then for the factor 2 only 6.238. So but you can see that cumulative frequency remains same, right? But when it's go to the rotation method, so you can see here that the first factor 19.01% is explained by the factor 1. Then go to the item 2, then again it's come 18.061, then it's quite same. So that's what we can use this rotation method. එතකොට මේ rotation method use කරන්න මෙන්න මේ හේතුව හින්දා එතකොට අර එකකින් වැඩියෙන් explain වෙන තියෙන එක අපිට අඩු කරලා හොඳ solution එකකට අපිට යන්න පුළුවන් වෙන හින්දා. Right, so the another one, then Varimax එක අපි use කරේ ඉතා method එකකට අපි ගිහිල්ලා ඕනනම් බලමු Varimax එකෙන්. Yeah, Varimax maximizes the squared loading so that each item loads moves onto single factor. අපි මෙන්න එක මෙච්චරයි වෙනස තියෙන්නේ analyze dimension reduction factor. Extraction is principal factor in that's okay. Rotation method එක අපිට change කරන්න පුළුවන්. Varimax, right? Varimax. Continue. Okay. මේ rotation method එක වෙනස් කරලා. දැන් අපි බලමු මේකේ වෙනසක් තියෙනවද කියලා. This one here you can see here 0. Then it's then these changes we can see. Varimax rotation method, total variance explained by 1.521. Here you can see 3.381. The differences between Quadramax and the unrotated solution, that maximum variance can be in the factor that is not in the first, right? So good for the distribution about more than one factor. එතකොට මේ අපිට Varimax not rotation method එක use කරන්න පුළුවන්. එක factor එකට වඩා වැඩියෙන් තියෙනවා. That's good. Right? ඒක මේක theory කියවන්න. Right? Theory කියවලා චුට්ටක් මේක ඔළුවට දාගන්න. මෙතන අපි කරන්නේ දැන් මේ වගේ එකක් තියෙනවා කිව්වට පස්සේ you have to find the theory related to this one. Okay? So here in this course we are explaining only the how we can do these methods using SPSS if we have some what you call that some if you need to think if you think that you want to read that more actually, so you have to refer some materials, then you can understand what is this, then try to understand what is how we can do this using SPSS. Then if you have any doubts you can read and understand that. Okay, yeah, then that oblique rotation, so we'll use another rotation method. Then a factor pattern matrix, partial standardized regression coefficient of each items with a particular factor, right? And also factor structure matrix and factor correlation matrix we can see there. Right. So running two-factor solution, principles acting code. Right. Analyze, dimension reduction, factor analysis. So we have to go for the rotation method, direct optimum, and yeah, rotated solution. That's okay. Then when delta equals to 0, here delta equals 0, this is direct quadratic, right? Larger delta increases the correlation among factors. So then we can change the delta value, then correlation is increased. Negative delta increase makes the factors more orthogonal, right? So the oblique rotation means that, so oblique, if we use this oblique rotation means factors are correlated, right? Yeah. Factor correlation matrix, two-factor quadratic, right? Factor pattern matrix, factor correlation matrix, and factor structure matrix. The more we are continuing. Okay. Yes, we can see there. Yeah, we can take factor correlation here. For the factor correlation 0.6463, right? If all factors are orthogonal, the correlations between them would be equal to 0. Then the factor pattern matrix would be equal to factor structure matrix, right? The more correlated factors greater than difference between pattern structure matrix. For make it, factors are correlation with them would be equal to 0. 0, one of them that is equals to this method, right? Then go to the pattern matrix, structure and pattern matrix, two practice method. Structure matrix, pattern matrix, this is the structure matrix 0.653. This is structure matrix and this is pattern matrix. So 1.40, right? These values are there, right? Then I will try to compare this structuring pattern matrix, right? So partial standardized and revision coefficient can exceed 1, right? So here 0.740 is the effect of factor 1. This is effect of factor 1 on the item 1 controlling for the factor 2, right? Then here also same, that is negative 1.80 means that then effect of factor 1 from the item 2, right? The highest way to make that sum of the squared loadings equals to community think back into orthogonal rotation. So then here you can see these values that is quite equal sometimes. And sometimes you can see there are changes as well, right? Simple zero order correlation cannot exceed 1. So you can see here 0.653. 0.653 is the simple correlation of factor 1 on item 1, right? Note that sum of the square loadings not matches communities here. It is not matched there. And we can go for the communities here. Communities, yeah, that. These are the communities here. You can see that is in there. Then that is not matched here. So there is differences there. Right. Then total variance explained, we can go for this output. Total variance explained, this one it is explained there. 2.51, 0.59499. Then here we can see the values 2.381 and 1.931. Yeah, so this is the extraction and this is the rotation sum of the loadings, right? මේක අර ඉස්සලා ටිකමයි මෙතන ඇවිල්ලා තියෙන මේ ඒකම ඒ question එකම හින්දා, right? Now if you take the sum of the squared loading, now it's higher than the previous one. Because previous one is the unrotated solution, or then here there is a rotated solution. So yeah, then it's we discussed that that's correlations are increased if we use the rotated methods. And when factors are correlated, factors correlated වෙලා තිබන් sum of the square loadings cannot be added together to obtain the total variances. Right? එතකොට factors correlate වෙලා තිබ්බොත් එහෙම එතකොට factors වල ඇත්තට මේ correlation වෙලා තියෙන factors අපි එකට එකතු කරලා තමයි මේ variables හදාගන්නේ. එතකොට ඒවා correlated නම් ඔක්කොම, so actually we can't add the sum of the loadings to obtain the total variance. The total variance එක හොයාගන්න ඒක add කරන්න බැරුව යනවා. Right? Then again comparing the pattern to the structure matrix බලමු. Partial loadings are ඉස්සලා ටිකමයි. Direct quadratic rotation normalization pattern matrix. So this is the part diagram there. If we use direct quadmin with Kaiser normalization only for the loading shows, right? Then zero order loadings, you can see here in the method correlations there. Correlations are same, right? If these are correlated actually, lower absolute loadings in the items 4, 8 onto the text anxiety for the pattern matrix, right? So make a lower loadings there, right? So අපිට ඒවා අයින් කරලා ගන්න පුළුවන් actually. So that's what we have to do there. So make it අපිට දැන් ඒතර මේ relationship එකකින් ඇති වැඩක් නැහැ. So we can remove this, right? That is what we are doing in this fact analysis. සමහරවිට අපිට question එකක තියෙන items අයින් කරන්න වෙනවා through this fact analysis. Let's try structure matrix and the this is structure matrix and the pattern matrix. Structure matrix, pattern matrix. In the structure matrix, so these are the values. Pattern matrix, so these are the values. Right? Yeah. Yeah, that's enough actually. So then there are some other methods as well. Right? Here generating factor score is there, right? Right? So then we'll go to the reliability analysis. We put a reliability analysis fact analysis. Right? So the reliability, so you can read, that reliability is that what we call that fact analysis we are using for the actually what we call to check the validity. So the other thing is the reliability. To check the reliability, we have to go for a reliability analysis. So sometimes if that most common method is finding that Cronbach alpha values. So when you are finding the Cronbach alpha values, so it's if it is greater than 0.6, right? එක ගොඩක් හොඳ එකක් නෙමෙයි 0.78 වල ගියම තමයි හොඳ. But if it is greater than 0.6, that's front part value, so we can tell that our results are reliable. Then it's very easy. This worksheet, it's very easy to the convex alpha coefficient, right? It's very easy actually. We can go analyze scale reliability analysis. Analyze scale reliability analysis. Then we can take these all items here. So the method is, there are many methods, so we are taking the alpha method, right? So if you need item scales, then scale if item deleted, right? We can take, okay? Then Cronbach alpha values. What happens? Not selected, no. So we have to select this. Okay. Then you can see here. Then here Cronbach alpha value can 0.46 again. That is not a good model. Then ඒක ඇතුළු reliable නෑ අපේ. Then ඕන අපේ question එකේ අපේ reliability analysis එක එච්චර හොඳ නෑ. Then මේකේ පිට ඕනේ co item if deleted. Yeah, this one. Item of the, then I take that item if reliability if deleted. So if I need to increase our reliability, my reliability එක මට වැඩි කරගන්න ඕන. මේක 0.6 වත් අඩුම තියෙන්න ඕනේ කිව්වනේ. මෙන්න මෙතන ඇවිල්ලා තිබ්බම දැක්ක 0.6 එකක්. Cronbach alpha value if deleted. Main this one. මේක බලන්න. This one මේ. If I deleted this question from my data set, what happens? Then I can increase my reliability values for 0.662. So the better thing is that, so now my questions are not reliable with that question, so I can delete that item from my data set. So මම ඒ item එක අයින් කරලා දානවා. ඒක question එකකින් ඒ question එකම අයින් කරලා. Then I can go for the analysis. Then අපේ එක 0.6 වලට වඩා වැඩි වෙනවා. Then that's now it's quite reliable. ඉස්සලා තිබ්බ value එක ඇත්තට හොඳ නැහැ 0.4. නේද? ඒක ඒතකොට ඒක reliability එක ඇවිල්ලා නේ. ඒතකොට මගේ strong නෑ මගේ out මේ results ටික. Therefore I have to remove that. So then I can remove the item standard deviation excite me. Then my reliability is increased to 0.6. Right? That's what we are doing with this reliability analysis. Right? I think that is clear for you. Right. So those are the things actually I wanted to discuss with you throughout this course. There are many things, so there are many functions available in these pieces, but to do some kind of analysis, I think these things are enough. Right? Any more questions to ask? Any questions to ask? If not, we can finish this course. Right? Anything to say, any comment? Right? So if you need further clarifications, right? After that course also, you can have, if you have any questions when you're analyzing your data set, so we can help you, right? ඔයාලා පස්සේ උනත් කරනකොට මොන හරි ප්‍රශ්න තිබ්බොත්, so we can help you to analyze your data set. Doesn't matter. So then just I'm asking, so any comment about this course? So if you have any suggestions, so we can consider when we are doing another course actually. So that is better for us for the improvements. Anything to say? At least one person, so it's better for us for the improvements. මොනවද තේරුන්නේ නැද්ද?
Actually, thank you very much. I think we learned lots. Actually, this last class is somewhat difficult to, I mean, catch the things because so many things all together, so many methods and all things within 2 hours is little difficult, I think. But all other classes, I think if you follow, I mean, again and again, listening to your videos, I think it's good actually. We can catch some of the most of the things from your presentation, and very informative presentations. Actually, as much as possible, you explain everything, I think.
Yeah,
But only thing is actually at the limited time period, following the step by step is difficult. I think we need to go again and again through your videos and examples and everything. So anyway, I think I learned lots. I need to increase my knowledge, especially. So that's what I participated. Thank you so much.
yeah. Thank you for your comment. Then I think that so that the factor analysis is not familiar to you. So it is that you can, if you increase your theoretical knowledge, right? So then again go through this video. I think it's better for you. Then you can understand something. I know that this is actually so factor analysis is it's quite a complex thing, so then we need more time actually, but within that limited time, so I try to explain everything. So the thing is that so the content is there, so you have to take more time, then say then stop your video and uh, again do the analysis, then find the theory related to those things, then I think you can get something. Sorry about that because we can't explain step by step everything there because with the limited time. Right. Anyhow, that in next time we'll try to reduce some content from the another part, and we'll try to do that fact analysis in uh, for 2 days. Right. Okay. Thank you very much for that comment. Anything to say? The others? Yeah. So then with that, we can finish our course. So actually, this is not the, so if officially finish this course, if you have any problems related to your analysis, so you can ask from us. So then if you can, we can always with you to help you, right? So then thank you very much for the participating this course. Right?
Yeah, thank
Um,
you very much. Yeah.
okay, bye.